Hi, welcome back to the channel. Today we're going to be talking about LabVIEW's DAQmx palette, which is used to communicate with your data acquisition systems. But before we get started, please show some support by subscribing, dropping a like, or throwing a comment in the comment section below. Every comment, every like, every subscription helps the channel grow and make future content. So we're going to go ahead and get started, and we're going to need the measurement IO DAQmx palette. So let's go ahead and pin that just so we don't have to search. So there's multiple ways to get started. The easiest way is if you just do a simple DAQmx assistant block. This will basically do all of the heavy lifting for you, and as we'll see right now. So we can go ahead and acquire signals. In this case, we have a simulated device set up already. For simulated devices, please go watch the previous video on simulated devices. It's quite simple to set up, even if you do not have any hardware. So we're going to go ahead and click these 4 channels and click Finish. Now, this DAQ assistant basically looks very similar to, if not identical to, the Max setup. And as you can see, we can go ahead and immediately run end sample acquisition. Let's change that to continuous, and we can see that we're going to get continuous data. And now that's not necessarily what you might want, but it is a good way to start acquiring something without actually going to Max. But this, for most applications, isn't good enough. So what we're going to do is we're going to use the start and stop API, and we're also going to use a read API. So in this particular case, let's line them up. Let's wire everything. And let's give a little breakdown of what these are. Now, these are just very simple elements. Obviously, the start task is going to close the task that you're working on. The start task is going to start it, and this is going to read from the analog channel, single sample, and we're going to call that a waveform. So this is going to be read 1. Now we might want to read multiple channels, single sample, and we're going to do a 1D array. For now, we're not going to touch waveforms just yet. So in this particular case, we can't run this just yet because we don't know what task to run. So the simplest way to do things is if you already configure a task like I have in NIMax, for example, this my simulated 9205 task, we can grab its name because that's already a valid task in NIMax, and we can go ahead and either type it in like I did or select it from here. Now, all the tasks that you have available here should, in theory, show up here. Sometimes they don't. Sometimes you might have to browse or just hard code the name, but we can go ahead and do this. And you don't have to use this constant. You can also use a string. So this is just as valid if you do this. Really, at the end of the day, the task name in is a string. You can't really do that after the fact. You do need a, as you'll see, this is not the best way to do this. You can, but you shouldn't, because once you create the task, it's easier to keep track and know that this is a task instead of having this string. So we're going to go ahead and just use the DAQ task out. And because we want to do this in a loop, for example, we want to do this over and over again just to demonstrate, we're going to go ahead and create a stop button. This is the only condition that I would use for this, but it is a condition that allows me to quickly illustrate my point. So we're going to add a wait because we don't want to read this as fast as possible. There won't really be any real data. So we're going to go ahead and do this. And then let's just add a simple graph on the front panel, such as this. Or rather, let's add a chart so that we can show the history. And let's wire that chart to that 1D array. So if we click Control and then drag with the mouse, you can actually resize your block diagram. So let's go ahead and do that. And let's take the data out and wire that to our waveform chart. So we should be ready to start. Let's just make sure that that's cleaned up. And let's go ahead and run the task. So as you can see, this is our sinusoidal wave that we encountered previously here. Because our sampling rate is 10 hertz, this might not be the real sinusoidal wave just based on the sampling frequency. So let's go ahead and stop that. The application is not able to, yeah, okay. So the first thing that we've done is now, because we're essentially only reading at 10 hertz and we're reading one sample per channel, what ended up happening was our buffer on the DAQ overflowed. So we had an error because we weren't keeping up with the acquisition. So let's go ahead and read multiple channels, but let's do multiple samples. And we can do a waveform like this. And that won't be usable data. So let's go ahead and actually change that to analog, and let's change that to a 1D array of waveforms. So what you're reading from here now is you're reading a 1D array. So each element in that 1D is a waveform, and a waveform is basically, as we'll go over in a second, is made up of basically three things. Actually, let me just make create constant. So you'll see that this is an array of waveform, and what a waveform essentially is at the end of the day, it's a cluster, and inside it's got a timestamp, which is the time 0. So it's the timestamp of the first point. It's a DT, so which is the time difference between points, and then this is the array of values. So really, those three are the main ones that you should worry about. But they also have this variant attribute for other attributes that you might care about for the waveform. There's some that NI uses, such as signal name, etc. But overall, this is how you really care about the data. So that's why when you select, for example, analog, multiple channels, and you do a 2D double, it's just a 1D array of 1D arrays of the points, so it doesn't even give you the timing. So if we go ahead and start this, we'll see that over time we have the sinusoidal wave being graphed, and we also see that we have no buffer issues currently. Now you can set how many points you want to read at a time. There's more complicated things you can do. So for example, even on this waveform, you can say number of channels to read per sample. So instead of reading all of them, you can read, let's say, 100 of them. There's obviously, as you can see, many more advanced things that you can do in terms of setting up your DAQ, in terms of configuring your DAQ, in terms of configuring or creating the task. But for this case, we just kept it very, very simple and just showed you the very basics of setting up and running a simple task. Now, as you can see, this is analog data because we created an analog module and we created an analog task. Now, in here, you could do anything. You have obviously digital inputs and outputs. You have counters. You have raw data that you can get. You have analog, unscaled, scaled. There's a lot of things that you can do within the DAQmx palette, and we're going to go over future videos of how to do more advanced items. For example, one that is common that users might want is to actually not have to create and configure the task in Max, but to have everything be created in LabVIEW. And that's, for example, as you can see in the task configure, you can create a task, you can control tasks, you can add input-output buffers, you can also do more advanced items like synchronization between different modules, if those modules support synchronization. And you can also immediately log the file. So there are more advanced items that you can do. This is the very basics of reading from a task. So this is how you would get started. There's examples that LabVIEW provides, and they're almost identical to this. They also provide you synchronization examples and such, but it's important to go over each element and explain how they work in conjunction with each other, and also give you kind of an example of how they got to their logic. So again, if you have any questions, drop a comment in the comment section below. Please throw a like on the video and subscribe for more content. Every bit of support helps. Thank you.